Okay, let's start the session.
Let's start the session.
Okay, I'm starting the session.
Okay,
Rest will join in
I'm
media.
starting the session.
So,
Rest
my
will
name is
join in
Satyakam
media.
Pratap Singh,
So,
and
my
I
name
am
is
PhD
Satyakam
scholar
Pratap
here
Singh,
in IIT
and
Bombay.
I am PhD
And
scholar
this
here
is the
in
8th
IIT Bombay.
tutorial session
And
of
this is
this
the 8th
course
tutorial
Smart
session
Grid
of
Basic to
this
Advanced
course Smart
Technologies.
Grid Basic to Advanced
And
Technologies. And
before starting, the instructors of
before
this course are
starting,
Professor
the
MP Padhi sir
instructors
and
of this
Professor
course are
Premlata
Professor
Jana
N.P.
ma'am.
Padhi sir and Professor Premlata
So the
Jana ma'am.
topics we are going to
So
cover
the
today
topics we
are
are going to
this
cover
cyber
today are
security issue,
this cyber security issue,
demand side management,
demand side management,
and the methodologies, and some of the
and the
numerical based upon
methodologies,
this
and some
demand
of
side
the
management.
numerical based
Okay.
upon this demand
So
side
moving
management.
forward,
Okay.
so this is
So
the
moving
first
forward,
question related
so
to
this is the first
this
question
cyber
related
security
to
issue.
this cyber
So I
security
request I'm giving
issue.
2 minutes to
So I
solve this
request,
question.
I'm giving 2 minutes
Just
to
read the
solve this
question. This
question.
question is regarding the
Just read the
purpose of
question.
this
This question
optimal
is
PMU
regarding the
placement.
purpose of
PMU
this
I have
optimal
explained in
PMU
this
placement. PMU I
tutorial,
have explained
this
in
tutorial
this
session 2,
tutorial,
3
this
and
tutorial
4
session
also.
2, 3
And
and 4
what is
also.
PMU, how the
And
communication is being
what is PMU,
stabilized
how the
inside of this.
communication is being
And this is the
stabilized
first
inside
question.
of this.
Go through the
And this is
statements
the
and tell
first
me
question.
that which
Go through the statement
statements
and
are
tell me
correct
that
regarding
which
the optimal placement of
statements are
this
correct
PMU.
regarding the optimal placement of this PMUs.
I'm giving 2-3 minutes to solve this question.
I'm giving 2-3 minutes to solve this question.
You can write in the chat box also, and
You
you
can
can
write in the chat
open
box
your mic
also,
and
and you
also tell
can
the answer.
open your mic and also tell the answer.
And also, if you have any issue regarding
And
this
also, if
voice
you have
and the
any issue
video
regarding this
and
voice and
this
the video
presentation,
and
you can
this
write in the chat box
presentation, you
itself.
can write in the chat box itself.
Okay, I got one answer as
Okay, I
all are
got
true.
one answer as all are true.
Okay. Okay, let's
Okay.
move forward and
Okay,
read
let's
this
move
statement.
forward and read
So
this
what the
statement.
first statement is saying
So
that
what the first
the
statement
PMU
is saying that
installation is
the
limited by
PMU
economic and
installation is limited by
infrastructural
economic
constraint.
and
That is true because
infrastructural constraint. That is
if
true
you
because
see the right side image,
if
there
you
are
see the right
certain
side image,
buses are
there
there.
are
Suppose this
certain
is bus one,
buses are there. Suppose this
and
is
in
bus
the
1,
lower section, if you see
and
this is
in the
bus
lower
two,
section if you see this
bus
is bus
three.
2,
There are
bus 3.
multiple buses are there, and
There are
there are
multiple
certain
buses are
nodes
there, and
associated
there
with
are
it.
certain nodes
There are
associated with it.
multiple nodes connecting
There
with
are
it with
multiple
multiple
nodes
number of
connecting with
buses.
the
So
multiple
there is
number
an
of buses.
economic constraint is
So
such
there
that
is an
you
economic
cannot
constraint
install
is
the
such that
PMU
you
at the all
cannot
location.
install the PMU
So
at the
you
all
have to
location.
make a
So
certain
you have
algorithm and
to
see
make a
that
certain algorithm
what are
and
the
see
optimal
that
places
what are
where
the
the PMU
optimal
can fit,
places
and
where the
it
PMU
collects
can
the
fit,
data
and
during the
it collects
disturbances
the
and
data
the
during
healthy
the
condition itself.
disturbances and the
So
healthy
this
condition
is
itself.
major
So
important part
this
of this
is
PMU.
major
Optimal
important
PMU
part of
placement
this
is such that
PMU. Optimal PMU
it is
placement is such
limited
that
with respect to the
it is
economic and
limited with respect to the
infrastructural
economic and
constraint. First statement is true.
infrastructural constraint.
Coming to
First
second part,
statement is true.
that
Coming
is the
to second
critical
part,
buses, generator
that is the
buses,
critical
tile and
buses,
buses are
generator buses, tile and
prioritized
buses
for
are
the close monitoring. That is true.
prioritized for the close
Why?
monitoring. That is
Because the
true.
critical buses
Why?
are such that
Because
which
the
are
critical
prone to
buses are
generous
such that
levels.
which are
Suppose
prone to
the
generous
fault which is
levels.
occurring,
Suppose the
suppose there are
fault
two
which is
buses,
occurring,
1 and 2,
suppose there are two
and
buses, 1
through the
and 2,
past
and
experiences such
through
that
the
the
past experiences
first
such
bus
that
is
the
more prone to fault
first
as
bus
compared
is
to
more
bus
prone
2.
to fault
So
as
bus
compared
1
to
given
bus 2.
priority as
So
compared
bus
to
1
bus 2
given
because
priority
bus
as
1
compared
have
to bus burst 2
higher
because burst
priority
1
in
have
compare to
higher priority
as
in
compared to
compare
second
to
in
as
case of the
compared to
faulty
second
situations.
in case of the
So
faulty
the generator
situations.
buses,
So
critical
the
buses,
generator
and the tie line
buses,
buses are
critical buses, and the
prioritized
tie
for this
line buses
close
are
monitoring.
prioritized for this close
Coming to the
monitoring.
third part, that is the
Coming to
PMUs
the
are
third
costly.
part, that is the
Optimal
PMUs
bus
are
locations
costly.
are needed to
Optimal
be
bus
found to
locations are
reduce
needed to
overall
be
PMU
found to
installation.
reduce
That's true.
overall PMU
PMUs
installation.
are
That's
actually
true.
costly.
PMUs are
So
actually
you have
costly.
to see the
So
optimal
you have
locations
to
so that
see
you
the
can
optimal
minimize the
locations so
reduce
that
the
you can
number,
minimize the
so that you
reduce
can
the
reduce
number,
the cost.
so that you can
Cost,
reduce the
cost
cost,
related to installation
cost
and
cost
cost
related to
related to
installation
data
and
monitoring. Okay.
related to data
So
monitoring.
coming to the
Okay.
second,
So coming to the
that is the
second,
model,
uh,
that is the
that is the
optimal
model,
PMU placement
that is the
model.
optimal PMU
If you see in
placement
this
model.
figure,
If you
we
see
have
in
a
this figure,
certain network data.
you have a
Network data,
certain
how you
network
get
data.
this network
Network
data?
data, how you
Because
get this
by
network data?
monitoring either the
Because
certain
by
buses and
monitoring either
certain nodes
the
in your
certain buses
power
and
system
certain nodes
network,
in your
based
power
upon
system
that,
network.
this
Based upon that,
base case
this
DC OCF is
base
there.
case
So
DC
it is
OCF
such
is
that
there. So
certain base case
it
you
is
have
such
to
that
take
certain
for the
base case you
monitoring
have
of
to
this
take
network data.
for
Then
the
the true
monitoring of this
results are
network data.
monitored.
Then the
Okay.
true results
Then
are
all the
monitored.
data
Okay.
goes into
Then
is
all
this
the data
box.
goes into
This
is
box
this
is such
box.
that this
This
have a
box is
certain
such
cost
that this
optimization
have a certain
algorithm.
cost
Second,
optimization
it have
algorithm.
state
Second,
estimation
it have
constraint,
state
and third is the
estimation constraint, and third is the
observability constraint. Based
observability
upon these
constraint.
three factors, the
Based
first,
upon these three
second,
factors,
and
the
third,
first, second,
you
and
decide
third,
this optimal location
you
of PMUs.
decide this
How?
optimal location of
Because
PMUs.
if you have a
How?
network data,
Because
okay,
if you have a
so you
network
have the
data,
what kind
okay,
of data?
so
That's
you have the
power,
what kind of data?
Q,
That
I,
power,
V,
Q, I,
frequency, df by
V,
dt kind of thing,
frequency,
rate of change
df
of
by dt
frequency.
kind of thing,
So
rate of
this
change of
kind of
frequency.
parameters you
So this
already have,
kind of
and
parameters
by
you
the
already have,
observing of these
and by the
parameters and
observing of these
putting us
parameters
in
and
certain
putting
algorithm
us
which you made
in
for this
certain
PMU cost
algorithm which you made
optimization,
for this PMU
then
cost
you see
optimization,
this state
then you
estimation
see this
constant. State
state
estimation is
estimation
such that
constant. State
your
estimation is such
voltage
that
should not
your
go
voltage should
below
not
5%, that
go
is 1
below
and above
5%, that is
1.05.
1 and
This is the
above
state constant.
1.05.
And
This is the
also is such
state
that you have
constant,
a circuit
and
breaker.
also is such that
And
you have a
circuit breaker
circuit
is such
breaker,
that
and
it
circuit
should
breaker
trip
is such
when the
that
I is
it
greater
should
than
trip when
certain
the
rated
I is
threshold.
greater than
So
certain rated
your
threshold.
state is such that
So
you should
your
maintain the
state
I
is such
equal
that you
to
should maintain the I
this
is equal to
nominal voltage, nominal
this
current, which
nominal
should
voltage,
flow
nominal
inside of
current,
this
which should flow
inside of this your conductors.
inside of this
So
your
that is kind of
conductors.
state
So that is kind of
estimation
a
constant.
state
And the
estimation constant,
observability constant
and
is
the
such that
observability
what
constant is such that
the parameter
what
you should observe.
the
Based upon
parameter you
that,
should
this
observe.
optimal
Based
location of
upon
the
that, this
PMUs is
optimal
considered.
location of the PMUs is
That is the most
considered.
important part.
That is the
Third,
most
coming to
important
this
part.
Excuse me.
methods
Third,
and
coming to this
advantages and
methods
Uh,
and
disadvantages of it.
advantages
you
and
have just
disadvantages of
mentioned
it.
Yeah.
this
There are
observability
yeah,
criterion. Can you go to the previous slide? And state estimation constraints. Okay.
okay,
So, how that economic part is
yeah,
integrated? We have listed that economic criteria is also there, right? So,
yeah,
how?
Yeah.
yeah,
Okay. Okay. Okay.
okay,
So
okay, okay.
you have certain algorithms
So
such that
you have
you are
certain
having
algorithms
the
such that
multiple
you
number
are
of
having
buses.
the
Suppose this is a
multiple
your
number of
network,
buses. Suppose
and
this
you
is a
have a
your
certain
network,
buses
and
associated
you
with
have a
this,
certain
and
buses
each buses
associated
are
with this,
interconnected
and
with this
each
some
buses are
other network.
interconnected
So
with this some
you
other
want
network.
to
So
place
you
the
want to
PMUs. Suppose there are three
place the
locations. You
PMUs.
want
Suppose
to
there are
place
three
this
locations.
PMU.
You
Suppose
want
this is
to
one,
place
two,
this
and three,
PMUs. Suppose this is
and
one,
you
two,
know
and three,
that this third
and
buses
you
have
know that this
suppose you have
third
a high
buses have
RE
suppose
penetration
you have
kind
a
of thing,
high RE
and you
penetration
have
kind
this
of thing,
LVRT and
and you
HVRT
have
and
this
HVRT
LVRT
kind of
and
thing. So
HVRT
this
kind
is
of thing.
RE. This
So this
third
is
node
RE, this
is more prone to the
third
RE
node
penetration
is
is there.
more prone to the
So
RE penetration is
considering
there.
that
So
situation such that
considering that
suppose the
situation
fault
such that
occurs and this
suppose the
LVRT
fault
and
occurs
HVRT
and
this
this LVRT
tripping
and
happens.
HVRT this
So this
tripping
third
happens.
node is
So this
more prone
third
to
node
this
is more
vulnerability in
prone to
case of
this
the
vulnerability in
intermittency of
case
this
of the
RE based
intermittency
situation.
of this
And
RE
coming
based
to this
situations.
state estimation,
And coming
state
to this
estimation is
state
such that you have
estimation,
a
state
multiple
estimation says
multiple
that you
factors.
have a
Suppose you have a current,
multiple
you have a
factors. Suppose
voltage,
you have a
you have
current,
a
you have a
suppose you have a
voltage, you
frequency.
have a
There are
suppose you have a
individual
frequency.
constants are
There are
such that. such
individual
that your
constraints are
frequency
such that
should not
your frequency
go
should
below
not
this
go
less
below
than
this uh,
0.02, that is
less than
50
point zero 0.02, this
below
is 50
48.5
below
and
48
50.5. That
0.5
is the one of the
and
constant.
50.5, that is
Second,
the one of
voltage
the
is such that
constant. Second,
1.05 pu
voltage
to
is such that
0.95 pu.
1.05
So
pu
these
to
are the state
0.95 pu.
constant.
So
State
these are
constant
the
such that you
state
have a
constant.
multiple
State constant is such that you have
states.
a
State
multiple
is the current,
states.
voltage,
State
frequency,
is
rate
the
of change of
current voltage
frequency,
frequency, rate
and
of change of
inertia.
frequency,
Inertia. These are
and
the states. And
inertia,
based
these are
upon
the
that, you
states,
factor, you
and based
consider the
upon
factor
that
inside of that,
you consider
and
the
based
factor
upon
inside
that,
of that,
you
and
follow
based
this
upon
all the
that
constant,
you
and
follow this all
inside
the
of this
constant,
cost
and
optimization.
inside of this cost
Observability
optimization.
constant is such that,
Observability
suppose
constant is
your
such that,
voltage is
suppose
1.05
your
pu and
voltage is
it exceeded
1.05 pu
above
and
of
it
that,
exceeded
and in
above of
continuous
that,
monitoring, and
and in
you see
continuous
that
monitoring,
the
and
number of
you
times
see
it
that
go, it is
the
number
number
of
of
10,
times it
and
go,
you
it
see
is
the
number of
second,
10,
suppose you take
and
the
you
bus
see
2,
the second,
the
suppose you
number of
take the
times it
bus
is
2,
goes to 2,
the number of
number
times
of
it
time
is
it
goes
go
to 2,
above of that
number of times
is
it
2
go
times.
above of
So
that
at
is
which
2 times.
location you should
So at which
put
location you should
this PME? You
put
should put it
this
at a
PME?
tenth
You should
this
put
number
it
of
at a
where the
10th
10
this
times
number
it go
of
the
where
above.
the 10
You should
times
put
it
at
go
that
the
optimal
above,
location.
you
So
should put at
this is
that
a kind of
optimal location. So
observability constant.
this is a kind of
Observability constant
observability
is such that
constant.
you should take the
Observability constant
consideration
is
of
that
this
you
such that
should take the
you
consideration of
where
this
the
such that
voltage
you
exceeded the
where the
your
voltage
threshold
exceeded the
multiple
your threshold
more number of times.
multiple more number
That
of
is the
times. That is
observability
the
constant.
I got your point.
observability
Mukul,
constant.
you
Let
got
me
my
summarize.
point, or I
Actually,
should
we
Mukul, are
are
you
explain?
doing the
got my
DC
point, or
OPF
I
and
should
finding the
explain it further?
parameters and then feeding that to the cost function. Okay, this PME
Okay,
cost function, we are subjecting the constraints to this state estimation constraints and
okay,
observability constraints. Okay,
okay,
so observability, I was in the purview like some kind of this controller observer mode. That
Okay,
kind of thought came into my
okay,
mind. That was there. So you
okay,
have made it more clear on that. Thank you.
okay.
okay,
Thank you.
okay.
Moving to
Thank you.
this further
Moving to
methods,
this
advantage and
further
disadvantage,
methods,
there are
advantages and
multiple methods
disadvantages,
related
there
to
are
this
multiple methods related
optimal
to this
location
optimal
calculation.
location
Suppose one of the method
calculation.
is GA.
Suppose one
This
of
is
the
also
method is
important for your
GA.
assignment
This is
itself.
also
That is
important
a
for your
genetic
assignment itself.
algorithm, one
That
of
is
the
a
kind, and it
genetic
has certain
algorithm, one of the
advantages such
kinds,
as
and it has certain
it is
advantages such
adaptable to
as
this situation.
it
Why?
is adaptable
Because
to
it
this
learns
situation.
from
Why?
the
Because
situations
it
which are
learns
already
from the
existing into
situations
this
which are
network.
already
So
existing
this
into
is
this
adaptable.
network.
And
So
second
this
is
is adaptable.
immunity
And
GA.
second
Provide
is
this also provide
immunity
the
GA.
optimal solution.
Provide
But
this
the
also provide
problem
the
in this,
optimal solution.
because
But
the
the
learning
problem
part
in
is
this,
there, so the
because
large
the learning part
education
is
time
there,
is
so the
there.
large
Because it
education
have to
time is
consider
there,
the
because
factors
it's
which are
have to consider the factors
initially
which are
fitted into the system.
initially
And
fitted
second is
into
the
the
binary
system.
search. Binary
And
search is
second
such
is the
that
binary
zero or
search.
one
Binary
kind
search
of
is such
situation
that
where
zero
to
or one kind of
the
situation where
voltage
to
exceeded or not kind of thing.
voltage
So
exceeded
this
or
is a
not
kind
kind
of
of thing.
exhaustive
So
search.
this is a kind
So
of
the search
exhaustive
is
search.
very at
So
a
the
higher
search
level.
is
It
very
should
at
happen
a
inside of
higher
this.
level. It
So
should
the
happen inside of this.
disadvantage of this,
The
this time
disadvantages
consuming
of
and
this,
not tested on
this
the
time
larger
consuming
IEEE
and
bus
not
system
tested
that
on the
is
larger
already given
IEEE
into
bus
your
system that is already given
slides
in
itself
your
on the NPTEL.
slides itself
And
on
other
the
methods are
NPTEL.
integer
And
programming,
other methods
BPSO
are
method, and the
integer
tree search
programming,
and
BPSO
topology. That is
method,
a
and the tree
decision.
search and topology. That is a
Currently,
decision.
we actually use this
Currently,
decision
we
tree based
actually use this decision
methodology
tree
to
based
check whether the
methodology
where
to
to place the
check
PMVs.
whether the
We
where to
go
place the
from the
PMVs.
one node
We
to the
go
multiple
from
nodes.
the
Based
one node
upon that,
to the
check
multiple
whether
nodes. Based
we
upon
can
that,
place or not.
check whether
If we
we
can
can
place,
place or
that is
not.
fine. We
If
cannot
we
place,
can
then
place, that
we
is
go
fine. We
to the
cannot
other
place, then
solution,
we
then
go
check.
to the
Then
other
further we
solution,
could check
then check.
inside of
Then
that
further we could
node,
check inside
then
of
other.
that
This
node.
kind of
Then
system
other.
we actually
This
follow in
kind
the
of system
decision tree
we
kind of thing.
actually follow in the
This is
decision
a
tree kind of
simple
thing.
logic and
This is
the
a
PMV
simple
placement,
logic
but
and
the
the
problem is
PMV
such that
placement,
it
but
is
the
suitable for
problem
the
is such
power
that it
system
is suitable
which are
for the
already
power
equipped
system
with the few
which are
observable
already
islands.
equipped with the
Okay,
few observable
non-optimal
islands.
results.
Okay,
Okay,
non-optimal
and
results.
coming to
Okay.
this second part, that is
And
a
coming to
cyber
this second
physical
part, that
system
is
which
a,
are there
cyber
inside of
physical
this power
system which
system.
are there
So
inside of
the
the power
cyber
system.
security is a one of
So the
concern.
cyber
So
security is a one
for
of concern.
mitigating of this
So for
and
mitigating of this, for
going research part, that is the
going into
multiple
the
points.
research part, that is
So
the
you have
multiple
to
points.
understand this
So
why,
you
what
have
is the
to
cyber physical
understand this
system,
why,
and the
what is
how
the
the
cyber physical
layer by
system, and the
layer is
how the
their
layer
installation
by
is there
layer
inside
is
of this
their
power system
installation
network.
is there
So
inside
I
of
have
this
put
power
it
system
one
network.
question
So
related
I
to
have
this
put it
cyber
one
physical
question
system,
related to
and
this
you
cyber
should go
physical
through this
system,
five
and
statement
you
and tell
should
me
go
that
through
which
this five
statements are
statement
correct
and tell me
related to
that
that.
which statements are correct related to that.
I'm giving you 4 to 5 minutes
I'm
to
giving
solve this
you
question.
4 to
In
5
case of
minutes to
any
solve this
doubt,
question.
just
In
open
case
your
of
mic
any
and
doubt,
ask.
just open your mic and ask.
Okay, Gokul is saying the all are
Okay,
true.
Google is saying the
Okay,
all are true.
any other
Okay,
answer?
any other answer?
Pradyuman, Shiv,
Pradyuman,
Shivna, you can also
Shiv,
try this question.
Shivna, you can also try this question.
If you got this first
If you
answer as a true or
got this
false, you can
first
also
answer as
write
a
in the
true
chat
or
box,
false, you
or
can also
you can
write in the
open your
chat
mic
box,
and
or
tell
you can open your mic and tell
at least two.
at least two.
Okay, Pradyuman is saying true, true, false,
Okay,
false,
Pradyuman
and
is saying
true.
true, true, false, false, and true.
I got two answers.
I got two answers.
Okay, let's come to the
Okay,
solution part.
let's come to the
Actually, this
solution part.
power system network,
Actually,
if you
this
see, you
power
have a
system
certain
network, if you
equipment
see,
layer
you
is
have
there.
a certain equipment layer
You
is
have
there.
multiple number of
You have
equipments such as
multiple number of
transformers
equipment
and
such as
other
transformers and
equipments are there.
other
And above
equipments
of
are there.
that, you have
And
physical
above
layer.
of that, you have physical layer.
Physical layer, how it comes? Because
Physical layer,
for
how
the
it comes? Because
monitoring
for
purpose
the
and control,
monitoring purpose and
monitoring and
control,
control, you
monitoring and
put
control,
certain communication
you put
network,
certain communication network,
communication network, and control
communication
features
network, and
and control
control
features.
features,
For
and
that, you
control
need
features.
certain number of
For
sensors,
that, you need certain
certain
number of
number of
sensors,
controllers for
certain
that.
number of
And
controllers
between the
for that.
controllers and
And between the
central management
controllers and
system, you need a
central
certain
management
communication
system,
network.
you need a
Okay.
certain
So
communication
this
network.
kind of
Okay,
networks are
so
more
this
prone to
kind of
this
networks are more prone to this
cyber security issue. So
cyber security
if you
issue.
read the first
So the
statement, what is
if you
saying that
read the first statement,
cyber
what is
physical
saying
system in
that
the smart grid
cyber physical
integrate the
system in the
digital
smart grid
communication and the
integrate
control
the digital
technology with
communication and
physical
control technology
infrastructure to
with
enhance the
physical
grid efficiency
infrastructure to
and
enhance the
reliability.
grid efficiency
Physical
and
infrastructure is
reliability.
such that there is a
Physical
conventional
infrastructure
power
is such
system
that
network
there is the
or
conventional
the
power system network
that is smart
or
grid kind of
the
thing
that is
with the
smart grid kind of
equipments
thing,
which were there inside
with
of
the
that.
equipments which were
Second
there
is such
inside
that
of that.
to enhance the grid
Second is such
efficiency and
that to
reliability.
enhance the
That is
grid
true.
efficiency and
Because the
reliability.
control
That
and the
is true.
communication part
Because
is
the
very, very
control and the
important for
communication
this
part is
smart grid
very,
for
very important
maintaining this
for
grid
this smart
efficiency and
grid
the
for
reliability.
maintaining this grid efficiency
Coming
and
to
the
the
reliability.
second part, that is the
Coming
cyber
to the
physical
second
system
part, that
enables
is the
the
cyber
real-time
physical
monitoring.
system
That is true.
enables the
We see
real-time
that there
monitoring. That
is
is true. We
third
see that there
tutorial
is
sessions and the fifth
third
tutorial session
tutorial
that
sessions and the
how the
fifth tutorial
PMUs
session that
communicate
how the
through
PMUs
GPS.
communicate
Okay.
through GPS.
So control of
Okay,
this power generation,
so
transmission,
control of this
distribution, and
power generation,
communication with the
transmission,
smart grid.
distribution,
Second
and
is true.
communication with the smart grid.
Coming to this
Second is
third
true.
part, that is the
Coming to this
implementing
third part,
cyber
that is the
physical system in the
implementing
smart grid
cyber physical
introduces
system in the smart
vulnerabilities to
grid
the cyber
introduces
attack, potentially
vulnerabilities to the
compromising the
cyber
grid
attack,
security and
potentially
stability. That
compromising the
is true.
grid security and
And
stability. That is true.
I wanted to give the example of this
I wanted to
Mumbai
give the
itself,
example of this
where
Mumbai
the
itself, where
small scale blackout came
small scale
due to this
blackout
cyber
came
security issue
due to
last
this cyber security issue
two
last
years back. Okay,
two
so
years
this
back.
is a kind of
Okay,
vulnerability
so this is
comes
a kind
when
of
this
vulnerability
smart
comes when
communication and the
this
control
smart
features you add
communication
into the
and
system.
control features you add
Coming to
into the
this
system.
fourth part, this
Coming to this
cyber physical
fourth
system
part,
facilitates
this
the
cyber
integration
physical
of the
system
renewable
facilitates the
energy sources
integration of
such
the
as solar
renewable
wind into
energy
the smart
sources
grid
such as solar
infrastructure,
wind into the
optimizing
smart
grid
grid infrastructure,
utilization and
optimizing
reducing
grid
denominator. That is
utilization,
false actually.
reducing denominator. That
Why
is
is this
false
false?
actually.
Because if
Why
you
this is
see the
false?
cyber physical
Because
system,
if
that
you
is the
see the
top
cyber
of this
physical system, that is
power
the
system
top of
network,
this
that is not
power system network,
have
that is
any
not
features to
have
integrate the
any
multiple number
features
of
to
equipment.
integrate the
It is
multiple number
just a
of
physical
equipment.
system which
It
is
is
the
just a
top layer
physical
of this power
system which
system
is the
network.
top layer of
Top
this
of
power
this power
system
system
network.
network.
Top of this
It
power
does
system
not
network.
facilitate any
It does not
integration of the renewable
facilitate
energy
any
sources. It
integration of
just
the renewable
provides
energy
this
sources. It just
security
provides this
and this
security
avoid the
and
vulnerability
this
to the cyber
avoid
attack.
the
Okay,
vulnerability to the cyber
it
attacks.
do not
Okay,
facilitate
it
any
do
Excuse
integration of
not
me.
this renewable energy
facilitate any
sources.
Excuse me.
integration of this
Upon
renewable
that,
Coming
energy
to this
sources.
fifth part,
see,
Coming to this fifth part,
dispatching
that is
of
the
this
deployment. Okay,
renewable energy systems, when it comes to dispatching,
okay,
ancillary support, and all, it is going to
okay,
be the upper layer that is going to control this. Okay. And it was
yeah,
discussed in the session
yeah,
also, like a false dispatch signal
Yeah.
or a false control signal could affect the frequency, something like that. So a robust system is required for the integration, right? In that
Okay.
sense, should be true, right?
Yeah.
Yeah.
Read this statement. What is saying that?
Read
It's
this
saying
statement.
that
What
the
is saying
cyber
that?
physical
It's
system
saying that the
facilitate the
cyber physical
integration of the
system
renewable energy
facilitate the
sources.
integration of the
You
renewable
should
energy sources.
this
You
install the
should
renewable energy
this
sources,
install
and
the
you
renewable energy
provide this
sources, and
communication and the
you
control feature.
provide this
But
communication
it
and
is
the control
not the
feature.
duty of the cyber
But it is
physical
not
system
the duty of the
that it
cyber
should
physical
integrate.
systems
That
that
is,
it
you
should
can
integrate.
integrate, but you
That is,
cannot
you can
integrate also.
integrate, but you
This is
cannot integrate
not
also.
this
This is
importance or the
not this importance or
facilitation
the
procedure or
facilitation
provider to this
procedure
integration
or
of the renewable energy
provider
sources.
to this integration of the
Are you
renewable
getting my
energy
point?
Still doubt
sources.
on that.
Are you getting my point, Gokul?
Okay, let me clear your
Okay,
doubt. Okay.
let me clear your
Suppose
doubt.
you have a
Okay.
certain equipment.
Suppose you
Suppose you
have a
have
certain equipment.
installed
Suppose you have
certain
installed
equipment, and
certain
you in
equipment,
above of
and
that
you
you
in
have a
above
cyber
of
physical
that
system which
you have a
provides
cyber
certain
physical system which
controlling features
provides
of that,
certain
and then you
controlling
communicate with
features of
this
that,
CMS,
and
central
then you
management system,
communicate with this CMS,
and then
central management
you
system,
CMS sends some
and then
data
you
to this cyber
CMS
physical
sends some
system through
data to
cyber
this
physical
cyber physical
system to
system
this
through
equipment to
cyber
on
physical
and
system
off,
to this
or
equipment to on and
make
off,
it
or
permanently off kind of thing.
make it
So
permanently
in
off kind of
between,
thing.
if you see,
So in
we
between, if
haven't
you see,
said that
we
the
haven't
renewable
said
energy
that
sources should be there.
the renewable
We are
energy
just
sources
saying
should be
that
there.
there is a certain
We are just
equipment
saying
is
that
there.
there is a certain
Above
equipment
of
is
that, you
there.
have a cyber physical
Above
system
of
which is
that, you have a cyber
communicating with
physical
some
system
third
which
party
is
network.
communicating with some third
But
party
if
networks.
you say that there
But
is
if
a
you
renewable
say
energy
that
sources,
there is
that
a
is fine.
renewable energy source,
It also
that
have
is
a
fine.
certain physical
It
system
also have a certain
which have
physical
certain
system
controlling and
which have certain controlling and
because you have a certain
controlling,
battery
and
storage
because
if
you
you are
have a
installing
certain
at a
battery
large
storage if you are
large part,
installing at a
then you have a one
large
CMS.
part,
Okay,
then you have a one
so
CMS.
here
Okay.
the renewable energy is
So
there.
here
Okay,
the renewable
then
energy
you
is
can
there.
control
Okay.
and monitor
Then you
and
can control
communicate kind
and
of thing you
monitor
can do.
and
Okay,
communicate kind of thing you
but
can do.
in the
Okay.
second network, both
But
networks are
in the
fine.
second network, both
What
networks are
common
fine.
features are there?
Both network,
Physical
what
system,
common
one
features are there?
CMS.
Physical
But
system,
there is
one
a
CMS.
possibility that
But there
renewable
is
can
a
be there,
possibility
renewable
that renewable
cannot be there,
can be
but the
there, renewable
fiber physical
cannot be there,
system
but the
must be there.
fiber
Okay,
physical system
so
must
this
be there.
physical
Okay.
system do not
So this physical
facilitate
system
this
do not
integration, but it
facilitate this
provides the
integration,
advantage
but
during
it
this
provides the
communication and
advantage
the control.
during this
Okay, you
communication and the
can
control.
connect to this
Okay. You
network the
can
renewable
connect to
sources,
this
but you cannot
network the renewable
if you
sources,
don't
but you
want you can
cannot
do.
Okay.
if you don't want, you can also.
Something
Okay.
similar to
Are you
a,
getting my point now?
small subset
Are you
and a
getting
whole
my
set.
point now?
Okay.
Yeah, that is the kind of thing.
Yeah, yeah. That is the kind of thing. Yeah.
Coming to this fifth point, that is the
Coming to
deployment
this
of the
fifth
cyber
point,
physical
that is the
system in the
deployment
smart
of the
grid,
cyber physical system in the
necessitates this
smart grid,
robust cybersecurity measures
necessitates
to
this robust
protect against the
cybersecurity measures to
unauthorized access,
protect
data
against the
breaches, and
unauthorized
disruption of
access,
the
data
critical energy
breaches, and
services. That
disruption
is
of the
true.
critical energy services.
Data
That is
breach is
true.
one of the major
Data
issues
breach
because
is one
if you
of the
see there
major
are
issue,
two
because if you
points
see
where
there
the
are
data is
two
going from.
points where
Suppose
the data is
it is
going
a two-way
from. Suppose
communication is there.
it is a
So
two-way
in
communication
between
is there.
the one
So
can
in
access
between
this
the
network,
one can
and
access
through the
this
first
network,
party it can go
and
to
through
the
the
second
first
party
party
also.
it can go to the second party
Second
also,
party physical
the
system. That is
second
also
party
kind
physical
of
system.
this
That is also kind
data
of
breach can
this
happen from the
data
two-way
breach can
path.
happen
Okay.
from the two-way path.
Coming to this
Okay.
uh,
Coming to this
next question, that is the benefits of
next
related
question,
to this
that is the
cyber physical
benefits of
system.
related to
Here
this
I
cyber
have
physical
given this
system.
four statement.
Here
You have
I
to
have
tell me
given this
that which
four statement.
statements
You
are
have to
true
tell me
regarding
that
this
which
benefits of
statements
this
are
cyber
true
physical
regarding these
system.
benefits of this cyber physical system.
Okay, I got one answer
Okay,
and
I
it's
got
all
one
true.
answer. It's all true.
Anybody else?
Anybody else?
Okay, Sadhu is saying
Okay, Pradvin
first
saying
three is true and the last is
first
false.
three is true and
Gokul,
the last is false. Gokul,
Shiv, you want to try?
Shiv, you want to try?
Anybody else? Okay,
Anybody
Gokul is
else?
saying
Okay, Gokul is
first
saying
three is true and the last is
first
false.
three is
Okay,
true and the
let's
last is
come to the
false.
solution
Okay,
part.
let's come to the
Let's
solution
read this
part.
statement first.
Let's read this statement
What is
first.
saying that the two-way
What is
flow of
saying
the
that
information and
the
the
two-way flow of the
electricity enables
information and the
dynamic
electricity
adjustment in the
enables
energy
dynamic
distribution,
adjustment in
promoting
the
grid
energy
resilience
distribution,
and the
promoting
adaptability.
grid
That is
resilience
true
and the
because
adaptability.
you
That
need
is
this
true
two-way
because you
communication
need
and
this
this
two-way communication
dynamic
and this
adjustment in this energy
dynamic
distribution
adjustment in this
network.
energy
Last time I
distribution
have also
network.
told that this
Last time I have also
uh,
told that
if you
this
have this TMS
uh,
setting
if
and
you
the
have
PMS
this
setting is
TMS
there,
setting
so
and the
in
PMS
that you
setting is
need
there,
this
so in
dynamic
that you need
adjustment
this
to the system.
dynamic
For that you need a
adjustment to the
certain
system.
control
For that you
central
need a
control
certain
mechanism
central
in which
control
you have that
mechanism
bidirectional
in
flow of the
which you have
information
that
can take place.
bidirectional flow
Okay.
of the information can
Coming to
take
this
place.
second
Okay.
part, the
Coming to
efficient,
this
safe
second
and
part,
secure
the
operation
efficient,
for the
safe and
power
secure
grid is
operation for the
achievable through the
power grid
integration of
is
the advanced
achievable through the
monitoring and the control
integration of the
system,
advanced monitoring and the
mitigating
control
risk and
system,
optimizing performance. That
mitigating
is
risk
true.
and optimizing
Coming to this
performance. That
third
is
part,
true.
the flexible
Coming to this third
coordinated
part, the
operation based
flexible
on local system
coordinated operation
variables
based on local
enhances
system
grid
variables
stability and the
enhances grid
responsiveness to
stability and the
changing demand and supply
responsiveness to
conditions. That is
changing
true.
demand and supply condition.
Coming to
That
this
is
fourth
true.
part, that is
Coming to
automation
this
and the
fourth
smart
part, that is
features for the power
automation and
grid
the
are
smart
primarily
features for the
focused on
power grid are
reducing energy
primarily focused
consumption.
on
That is true.
reducing energy
But
consumption. That
rather
is
than
true.
optimizing
But rather
energy
than
production,
optimizing
that is false.
energy production, that is
Because
false.
the optimization
Because
of this
the
energy production
optimization
is
of
also a
this
one
energy
kind of
production
thing.
is also a
Because
one kind
if
of
you
thing.
are this
Because if you are
automating any of the things
this
and you are
automating any of the things
managing
and
this
you are
demand side,
managing
so
this
in that
demand
case
side,
you need
so
this.
in
If you
that
are
case you
reducing
need
this
this,
energy
if you are
consumption,
reducing
the
this
demand side,
energy
then the
consumption, the demand
generation
side,
is also
then the
should be optimized
generation
based
is
upon that.
also should be
Okay.
optimized based upon that.
So
Okay.
fourth is false.
So
And in
fourth
the
is
right side
false.
image, if you see
And
this
in the
cyber
right
physical
side image,
system,
if
what
you
is
see
this?
this cyber physical system, what is this?
What is the needed kind of
This
thing are there?
what is the
The
needed
internet
kind of thing
for
are
this
there? The
communication, the
internet
embedded
for
system,
this communication, the
wireless
embedded
sensors,
system,
mobile networks,
wireless
satellite
sensors,
networks, and
mobile networks,
RFID
satellite
and the
networks,
IoT kind
and
of things.
RFID and
So
the
these
IoT
are
kind of
the some
things.
of the
So
benefits.
these are the
And
some
coming to
of the
this next
benefits.
part, that
And
is
coming to
the
this next part, that is the
disadvantage of the
next
cyber
part, that is the
physical system.
disadvantage of
There
the
also
cyber
I have
physical
given the
system.
five
There
statements.
Excuse
You
also
me.
I have
can
given the
either
five
pick a
statements. You
statement
have to
Not
tell me the which
particularly mentioned
statements
in
are the
the
correct answer.
lecture slides, but what is the specific
Yeah.
advantages of micro PMU systems? What level of this cyber security levels are applicable in micro PMU systems? Can you share a few words on that? Micro PMUs placement.
Uh, Actually,
Uh,
this is not
Actually,
my research
this
area,
is
and
more not
also
my
the
research
content
area,
which
and
is
also
provided in
the
this smart
content
grid
which
kind
is
of thing.
provided in this smart grid kind of
Also,
thing,
that don't contain
also
that
that don't contain
things.
that
But in the next class,
things.
I
But in
can
the
help
next
you in
class,
that.
I can help
And
you in
because
that.
this is not my research area,
And
my
because
research
this is
area is
not
the
my
EV
research area, my
integration.
research area is a
So if
EV
you want
integration.
certain kind of
So if you
documents or
want
certain
certain kind
slide
of
based upon
documents
that,
Okay.
or certain
from the
slide based
next
upon that,
tutorial
from
session,
the
I can
next
add.
tutorial session, I can
Okay.
add. Okay.
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 Thank you.
Thank you.
Coming to this,
Coming to this,
please try this
please
question.
try this question.
This
This
this question is
this
related to
question is related to
disadvantages.
disadvantages. In
In
the
the
next
next
class,
class,
I
I
will
will
provide you
provide you
with some
some
of
of
the
the
contents
contents
related
related
to
to
that,
that.
Gokul. Don't worry.
Farewell.
Okay, I got few answers that Google saying all are true. Vidyaman saying second is false. Okay, okay. Anybody else want to try? The last 1 minute, if you want to try. Okay, let's come to the solution part. Okay, if you see, let's read the statements first. The first statement is saying that cyber attack poses a significant threat to the cyber physical system. Mark this point that where it attack in the layer, and then potentially compromising the security integrity in the interconnected infrastructure. Okay, if the network is isolated, okay, you if the cyber attack is there, cyber attack happens, then you can simply just cut out that network, it which is prone to this, and then you can increase the reliability of the system. But what happens here that there are with this power system infrastructure, it is all are interconnected. You cannot just cut the supply, this set the load or kind of thing, and set this tie line kind of thing. You cannot do in this situation. Okay, so first statement is true. And the second part, that is the communication latency, the speed, okay, can hinder this real-time responsiveness of the cyber physical system. That is also true. Because if the two nodes are communicating, okay, suppose this is first and second. If if the rate of transfer of this signal from the first one is lower than this second one, okay, so the capturing speed, it should not, it will not be able to this capture the signal which is transferring from the signal, this node 1 to node 2, or this node 1 to CMS. What is happening that it should be time synchronized. Okay, the time synchronization is the one of the factor that you, if you are installing the equipments and you want to real time monitor or real time control the system, the time synchronization is must, the sampling rate basically. And also you have to take care of this, suppose the band which you provide between the two signals. Suppose this is two signals you want to transfer, then you should also see that the avoiding this overlapping region, you should take care of this sampling rate. Okay, which must be greater than the 2 fm, which I have told you in the previous slides also, previous lectures also. So this kind of latency can hinder the real-time responsiveness of the cyber physical system. That is true. Coming to this third part, that is a packet dropout. Okay, this is basically the transmission loss. Transmission loss of the communication loss, you can say. This is packet dropout in this communication network also disrupt the data transmission between the components of the cyber physical system, and also it leads to the inefficiency and the potential operation failure. That is true. Coming to this fourth part, that is the network jamming congestion can impede the flow of this critical information between the cyber physical system and resulting in delays and the compromised system performance. That is true. Coming to this last part, that is the malicious control effects initiated through the cyber attack can manipulate the cyber physical system to act against the intended purposes, causing safety hazard and operation disturbances. That is true. Here I wanted to give one example of this Iran. Iran is such that if they are developing some, they have certain nuclear project. Okay, so one situation came into this nuclear facility which was there in the Iran, that certain malware came and it disrupted the main that main part which actually this formed this main part, that is the uranium. and that major device or equipment which got tripped or became out of this network, this infrastructure network. So what happened that this sudden this failure of the one equipment got tripped, and it got cascaded to the other equipment as well. So all the network got interrupted at a sudden moment of time, and the whole of the network, it also caught the fire at the as well. The main most of the document got neutralized. Okay, so this is a kind of the headache of this cyber attack, that it should be controlled at a particular network, and it should have a certain kind of reliability, these features inside of that, so that you can make it more robust in the case of this cyber attacks. Okay, coming to this classification part, that is a cyber adversaries. If you classify this data manipulation attack, they are classified into two, that is the FEDI and the DOS based system. If you see the FDI, they have, if you have a certain sensors, controllers and communication links, then this data manipulation attack, they mainly consider on the sensors, controllers and the communication link. If you come to this DOS part, it mainly come to this sudden suspension of this communication network, whole of the infrastructure. And then MITM, which attack is unidirectional, can be unidirectional or the bidirectional, which I have already told that if that there are two nodes which are communicating, node 1 and node 2, there is possibility that the cyber attack malware came inside of this first system when during the transmission, and it get transmitted to the 2. Okay, when the 2 is coming back, this data transmission is flow is happening, then it is possibility that the 2 it also prone to this attack. Okay, for this 2 bi-directional kind of information flow. Okay, so this is kind of attacks are mainly coming to the DUS. Okay, so coming to this next part, that is the cyber security and resiliency. So there are certain statements I have put it forward. You have to tell me that which statements are correctly related to this cyber security and cyber resiliency. Okay, and after that I will explain further. Okay, go through these statements and tell me that which statements are true. Okay, first to fourth are true and the fifth is false. Okay, any other answers? Okay, I got one new answer. That is the the Pradyuman is saying second and third is false. Okay, any other answers? Anybody else who want to try this? Just if you are getting the one correct answer of the first statement itself, just write it. Okay, just give it a try at least. Okay, first is false. I got one answer. Last 30 seconds. Shiv, you want to try? Okay, let's jump to the solution part. If you see this statements, the uh, first statement is saying this: cybersecurity focus solely on the preventing the cyber attack. This statement is certain vague kind of thing because the while prevention the crucial aspect of cybersecurity, it also involves the detection, response, and recovery from the severe cyber incident. Okay, so this statement is not correct. If you see the mainly what we think that cybersecurity issue is such that you have a certain physical system which is robust, but the malware which comes, it is a non-detectable by this cyber physical system, which is very prone to this situation. So the detection, response, and the recovery, this all involved in this cyber incidents. Okay, so first statement is false. Coming to the second statement, that is the resilience in the cyber security refers to the ability to quickly recover from the cyber incidents. That is actually true. The recovery which is happens from the cyber set attack, that is actually the cyber resilience. Okay, you need the certain system, physical system, which must be mostly robust to this recovery and also recover from that situation itself. Okay, coming to this third statement, that is the effective cybersecurity measure can guarantee 100% protection against all cyber threats. That is false. Practically that is not possible because the if you see the incidents currently which was happen this India itself, that is the Mumbai cyber attack, one of the last this 2 years back, one of this AIMS Delhi attack. This all are actually the malwares which we have, which our system, this physical system is robust with those malwares, uh, and it is actually trained on the basis of that. But the malware which came on these two attacks are completely different, which was previously been learned from that. Okay, so this is completely false in the case of this practical scenarios. Coming to this fourth part, that is cyber resilience involve the anticipating, withstanding, recovering from, and involving to improve the cyber attack. That is true. That is false. Why? Because its cyber resilience involve anticipating, withstanding, recovering from, and involving the improve from the cyber attack, not to improve them. Okay, improving from the cyber attacks, but not to improve them. Because if you see, this attack should not improve. This cyber resilience should improve. Okay. Coming to this last part, that is a cyber resilience is a static concept that doesn't provide any continual adaptation to emerging cyber threat. That is false. False in the sense it should adapt to this continuously occurring cyber threats, which are actually very complicated to make your system to learn based upon that. So in that situation, one of the research areas is that where they are using this ML concepts to make the system more robust. If it learns if it connects the dot between this cyber system, the cyber threats, then it can make the system robust.
Excuse
Okay,
me.
so the attack tree, if you
Actually,
see
in a
the
previous
attack
slide,
tree
also you have
effects of the
shown as two domains, cyber security and cyber resilience as a two domains. Okay. So that was the reason why the first option was chosen as true,
okay,
because
okay,
security involves preventing cyber attacks and resilience is the adaptation part. That kind of domain splitting into two domains exists, or it is a whole term. Did you get my question?
actually this is, yeah. There are two terms here involved. That is the cyber security is the one feature. Resilience is the second term. Cyber security, if you see, cyber security, if you are installing a physical system or making a physical system, you based upon that you should make the system that what the initial incidents happened. Okay, and if you see the resiliency part, okay, so cybersecurity is such that it should protect when the this attack happens. Okay, resilience is such that it should bring back the situation back before the malware when happens. Okay, comes. So it is such that when the attack happening is the one situation, coming back from the this attack and making your system to the normal condition, that is the second situation. So in the first situation, there is the cyber security term I have defined. Second situation
So
is the
the
cyber
explanation
resilience.
of the
Okay.
that first statement being false, you have encompassed into the
You
region of this resilience. Can you put to the next slide explanation part?
okay.
While preventing is a crucial aspect, it also involves detection,
Okay.
response, and recovery.
Yeah.
So that comes in the second domain. That is what is my
Hmm.
question.
Okay. Okay. Here the actually when you install this cyber physical system, that is the maintaining this cyber security issue, then the resilience is one of the component of it. Okay, you cannot separate both. These are the two terms, but the domain on which it is being implemented is the same. Okay, but you cannot separate that this is the one system, this is only act for one situation, and second it acts for the second situation. So first trigger the second, that is resilience is one of the issue that if you detected this cyber attack, then the response must be there so that it can mitigate that attack. And the recovery from the cyber incidents is also on the same platform, that if you coded the certain part, then the this incidence is also must be one of the component of this.
Okay.
So the domain which involve these two terms is the same.
Okay.
Okay, and this is the two terms but they installed on the same platform. Okay. Are- okay, thank you. Okay, coming to this attack tree, if you see the attack tree, there are certain levels has been defined. Okay, if you see the level one, this top level failure, okay, this power system performance affected. Coming to this second part, that is the physical consequences. This this compromising this let's go from the level 4, this attack techniques. Suppose there is a compromising the situation, suppose the certain cyber attack came and it compromises the system, then it went to the cyber attack, this is level 2, where the malicious command to exciter and the prime mover reference setting through the SCADA system. If you have a generator and governor system and you have a certain settings, and this SCADA setting, this malware makes the system to compromise this security, and the reference settings should can be changed. And in the same domain, if you see this malicious demand side response commands also can be taken. So the one side is the this generation side, second is the demand side. Okay, this cyber attack coming from this one single part can affect the both systems simultaneously or separately. Okay, so the this system is more prone to this from the both ends, not from the one end, from the generation side also, from the demand side also. So coming to the generation side, if you see the frequency imbalance due to the drop in power generation side, if you see from the second, from the demand side itself, there is sudden drop of load. Both issues are led to certain compromising of this resiliency of this power system network also. So this both side situation can be prone to this cyber attack. And whole of the system, if you see this level 4, the top level failure, if the certain drop of the load is there, so frequency imbalance will be there. If the generation is got reduced, then also the frequency imbalance will be there. Then this both situation can lead to the power system performance. Okay, so this kind of system is the attack tree which has been defined, which says that the effects of malware in the compromised system, the flow of path from where it comes and from where it can finally can make the system vulnerable. Okay, these are the four levels. Coming to this next part, that is the cyber anomaly detection approaches. There are two types of actually architectures are there. First architecture is the centralized communication architecture. Second is the distributed communication architecture, that is peer-to-peer information sharing. If you see the first part, if you see the first part, there are certain nodes which has been defined. If you see, this is the first node, this is second node, this is third nodes, and fourth node, and you have a certain database. Okay, and all the communication, if you see this from the here nodes itself, it is coming to a central part from where the information is coordinated. Okay, so this database is such that it records that centralized network data during the kind of this physical anomaly, so mitigating and giving the response to each node, so what to do in certain situation and what command to follow. Okay, if you see the right side image, that is the distributed communication network, there are certain pockets are there. If you see, this is the one pocket, second pocket, third pocket, and the fourth pocket, and the each pocket have centralized, concentrated, and distributed operator center. So each node which are connected to this smart meters and the concentrator, it have a certain own database, own command centers, from where it can isolatedly bit out, informing this operation center can take the command. Okay, it do not have to go to this centralized system and then follow the command which are given to the system. It can take their own decisions, and also it be connected with this central operation operator, because if this suppose this distribution operator center have a certain command features, it got disrupted, then there is a certain situations that you have a certain backup of that, from where you should take the command. Suppose the cyber attack came directly to this command center itself and making this cut off from the other situation, other parts which are from where it is taking the information. So in this situation, there must be a operation center from where this all the pockets can be connected. Okay, so there have a central system and also the isolated systems can be there.
Excuse
Coming to
me.
this
In the
approaches,
previous
in this
slide,
centralized
that
detection
can be in
approach, there
different
are certain
geographical areas,
methodologies
right?
such as state estimation. Yeah,
Okay, and it will be communicating through a dedicated network,
it
possibly.
can be.
And at each level, it should have its own firewall and other security.
Yeah,
Well,
hmm. Yeah, yeah, yeah. That is true. Coming to this methodology part, there are certain centralized detection approach. What Gokul was saying initially, that observability kind of thing, which comes actually in the advanced communication feature, and a communication the control feature. So this state estimation is one of the that part. That state estimation from that control feature it comes. And coming this chi-square is one of the method, and residual based binary hypothesis. These are all are the methods which is being introduced in the centralized detection approach. If you see this non-centralized, that is decentralized system, it have a certain centralized method after approximation, because you are installing in the certain pockets. So the communication feature you can install based upon the latency, but the response time can be of a higher time duration, because it is a far end point of this from the central controller itself. Okay, so you can approximate the situation which are already there in the centralized system and install in that pockets. And second is the singular value decomposition based methods, and the other is the fault detection identification, that is the observer based. Here the controller part is there, what I was previously asked. Okay, so coming to this our this research potential research direction inside of this our cyber attacks and cyber physical system and resilience kind of thing. So there are certain areas and the scope of investigation are there. Suppose the first is the distributed attack detection, in the distribution network. So this is new technique for the distribution system if you want to install, because the both the system from the generation and also from the distribution also, both system are vulnerable, okay, which is connected to a certain central thing. Second is the concurrent attack detection, which is happening in the concurrent basis. That is a simultaneous attack on the multiple communication link, which need to be identified. Suppose, which I have explained in the decentralized system. If you see, you have a central system and you have a certain pockets also. If the pockets this security got compromised, you have a central system. What happens if the central part got both system got compromised at the same situation? That kind of concurrent attack detection is one of the is research area. Third research area is the scalable attack detection, because you are installing to the certain pockets and you have a central system. It also have certain issues. Certain issues is such that up to what length you should implement this communication network and data transfer issues. So that kind of scalability is one of the research area can be, that is extending the detection algorithm to a larger scale network, okay. Then the fourth research area can be detection of the other attacks. One technique could identify different categories of attack. Suppose the one malware came and your cyber physical system is learned from that previous attacks. It should also make that learning part effective in case of this new cyber issues which came into existence, okay. So this kind of research area can be one of the, here we can use this ML algorithms also and make to learn our physical system based upon the previous attacks, and make and also install plus certain kind of systems which you have done R&D, that it can be possible cyber threats. And based upon that, if certain malware comes, based upon the whole learning, you can detect and mitigate that issue in that part, okay. So this is kind of potential research direction. Coming to this, our next part, that is the basically this uh, current situation of the power network, and the other parts of this, what is the basically involving our power system network which is being involved. If you see this, this is the present situation what is there, and we have this RE penetration also there. Initially what was there, we have a coal based power plants and a nuclear based power plant, where there is just really centralized network is there. Suppose the communication is happening from one node to a single network node and taking on that, it node don't have any communication feature in between there. And also this is actually also the one-way communication only happening, where the information that energy is only flowing to this demand side, from the generation side to the demand side. If you see the present situation what is there, you have the RE penetration plus the conventional system is there. It have the decentralized communication features, such that the each node have a certain communication features between the each centralized pockets, and each pockets have communication with the other pockets also, okay. So this kind of decentralized communications are there, and there is a two-way communication and two-way power flow is possible in the current scenario. Suppose you have a self-generating, that is the PV-based power plant for your own home. You can install that and you can participate in the energy market in that situation also. You can earn the money and you can power, and this reduce the basis on this conventional power plants. And also there is certain limitation. If you put the large amount of this PV penetration in your homes, there is a possibility that the congestion can happen. Second point is that DISCOM can be in loss making. Why I am saying this? Because if you are bi-directional energy flow is happening, the DISCOM is a profit making body, okay. It should give certain energy to the consumers and earn the money from there. if you are installing the PV penetration inside your home, then what the discom will do in this situation? So there are certain rules, policies are there, and rules and regulations are there. Suppose I take the example of this Lucknow. Lucknow have a certain this rules is such that you cannot install the 30% more than 30% of power which is actually when you have taken from this discom. Suppose you have installed you have taken the supply of the 1 kilowatt. You only install the 300 watt PV installation inside your home. So this is only to make the discom profitable in one sense, and it should not overburden the discom to make the infrastructural changes in the present scenario. So it is kind of different from the present scenario, and they make the investment after 3 to 4 years. Okay, after 3 to 4 years, so that it can take the time and the installation can be done and the reduction in the cost can happen. So this kind of present scenario is actually there. So this is one kind of research area is there. So coming to the our second part, that initial part was there related to the cyber security. Our second topic is related to this power system inertia. This is also one of the important topic. So before coming to this inertia, actual definition of this inertia, I have given the multiple five statements. You have to just guess that which statements are correct and which statements are false. Just make a intuition that this can be a certain definition of this inertia. Okay, just guess, or if you know that, you can give the answer. Okay, just try that. Okay, first three five one three five are true, and the rest two and four are false. I got one answer. Anybody else want to try? You have 2 minutes to solve this question. Okay, one I got second answer. One, three, four, five are true. One, three, four, five are true. Okay. Anybody else? If you got one as a correct or true or false, you can also reply in the chat box so that I guess that somebody is trying. Okay, one question is there. RE inverters and battery energy storage system PCS has synthetic or virtual inertia. Synthetic has synthetic or virtual inertia. That is true. It have the virtual inertia. To the DC link, it can give the power which are actually there in the DC link for the certain time duration. We will study this also in the further slides. We have the certain component that how this battery energy source system and this inverter based resources can provide this virtual inertia. Okay, coming to this answer part, just read the statements. What the first statement is saying that power system inertia refers to the ability of a power grid to resist sudden change in frequency without significant deviation. That is true. Because if you see that what the main focus area currently in the research area is that if the RE penetration, we are mostly have this inverter based resources IBRs, and the conventional we have this coal, hydro, nuclear, and this PV wind system, which is certain DFIG based system, and the other wound rotor based system, rotor based this turbines are there. So these are a high inertia kind of thing. And if you see this inverter dominated resources, we have this PV plants, wind plants, and the energy storage system. What is happening that if you see the type 3 wind farm, it have DFIG. If you see the type 4 wind farm, it have the mainly this power electronic converters only. Power electronics converter. It don't have any facility of this power conversion through the separate part. So separate part. Okay. It have a single stage power conversion. Okay. In this situation, what is happening that this sudden when this frequency change happens, it do not follow that characteristic which was initially was there, that sudden resistance. Okay, so this fast system inertia refers to this power grid. Okay, refers to the ability of that grid to respond when the sudden change in frequency happens. Okay, so first statement is true. Coming to the second part, that is the power system inertia represent the resistance of the electrical component within a power plant to changes in the electrical network. Actually, that is false. Why false? Because it should not resist. Okay, it represents the resistance of the electrical component. That is not true. It is not resistance. Okay. And coming to this third part, that is the power system inertia is a measure of stored kinetic energy in the rotatory machinery within the power grid. That is true. Because what we are saying that this energy, half j omega sm square, what is being converted and provided during this sudden changes frequency deviation. Okay. Coming to this fourth part, that is the power system inertia is irrelevant in the renewable energy systems as they primarily rely on the static energy sources. That is false. False in what sense? Because this inertia part is merely is a problematic during this RE penetration. So this is relevant in this situation. So you have to buy this virtual inertia, or you have to make a certain procedure that this should provide during this kind of situations. Okay. Coming to this fifth part, that is the power system inertia plays a crucial role in maintaining grid stability during disturbance such as sudden load changes or the fault. That is true. So let's you make you a certain kind of a situation where your conventional power plant provide this inertial support. Let me take you one example and how this PV based power plant can provide inertia. Suppose you have a conventional power plant, suppose you have a coal based power plant. So what is happening that if you have a certain generation from this coal based power plant, suppose this is the PG generation, constant, I am considering it a constant all the whole time. Okay, so what is happening that you should not use it and dispatch the whole power completely. So there are certain margins are there. Okay, if you explain from this whole capability curve also, you have a certain P and you have a Q. So it have a certain limits, that is the p min, and it also have the p max limit, and it also have this q limit as well. Okay, if you see this, q limit is also there. So your power plant is operating in this field. So what is happening that without going to the p max, you provide a certain margin. Certain margin is such that during this kind of situation that delta f change happens, okay, and the sudden this large amount of power demanded. In this situation, you can utilize this above marginal power, that is the P max minus P marginal power during that situation. And the same concept has been utilized during this RE situation. If you see this RE situation in the PV based power plant, what is happening there? If you have a certain PV plant, okay, you take the power from the PV and store in the battery energy storage systems, that is batteries or any other systems, that is ultra capacitors. You should not utilize the whole power at a certain moment. Okay, you give certain margin. Suppose you have a total capacity of S X max. You should not utilize that. What is the utilization is there? Only till X marginal. X marginal till X marginal you should use. And this X marginal, my X maximum minus X marginal, is a kind of stored energy inside of certain delta F changes. Okay, if the delta F changes, this battery response time, suppose it is a 1 millisecond or less than that, 0.1 millisecond response is there. So you can provide the virtual inertia from this energy storage system as well. Okay, for that you have to give there certain margin availability. That same situation happened due to the with the conventional power plant as well. Okay, so I have one more question related to this power system inertia. uh, just go through this question and tell me that what is the H total, what is the inertia, total inertia can be given from this all the generating power plants. Okay, how inertia related to the strength of the grid, X by R ratio, or how can you say that weak grid and the strong grid based on X by R? Can you please explain? Okay, just try this question. After that, I will explain this concept, that is X by R ratio. This is also one of the important concept, that is the how you should decide the strength based on this X by R ratio. Just try this question. Anybody who are not understanding this question, I will explain this further. Just write it in the chat box, or you can say, open your mic and tell me that you are not able to understand this question. Okay. That is saying that it only knows this swing equation. Based upon the swing equation, you can try that. Why? How? This swing equation, if you see there are number of generators will be there. The two concepts are there. If the generator is operating in the coherent swing is there, and second concept is incoherent swing. Incoherent is such that coherent swing is such that if there are two generators, they are operating at certain speed. So this the generator 1 should follow the dynamics of the generator 2, and the generator 2 follow the dynamics of generator 1. But that is not the case with the incoherent swinging. So generator 1 can operate by their dynamics itself. It should not affect the generator 2 dynamics. Okay, in that case. So what happens in the coherent swing? What we do that we just, if you remember this swing equation, that is GH by pi f d square delta by dt square is equal to Pm minus P. Okay. So if you see in the coherent swinging, this d square delta by dt square and this delta P is actually constant. Why? Because the rotating, what I have said you that it should follow the dynamics of this generator too. So this is the alpha, that is the accelerating part. The alpha, this delta p by alpha is constant. This delta p, if you are considering as a constant, so that's why this gh by pi f constant. So what we will do, g total h total is equal to actually g1 h1 plus g2 h2 plus G3 S3 plus dot plus summation of Gn Hn. Okay. So here what is saying that if you have a multiple generator such as generator 1, 2, 3, 4, 5, what is saying that it have an inertia constant of H1 of the 4 second and the power output of 100 megawatt. Okay. What is G? G actually unit is megajoule per MVA and the unit of H is MVA. Okay. So the energy, this is the energy part which is being supplied through the acceleration or the deceleration and the delta P change. Okay, if the delta P changes through the acceleration or deceleration, this energy is utilized. Okay, so in this situation, if you have this power is such that this is power multiplied by time of thing. Okay, so if you see this H1 multiplied by P1, here I have used this G and H part. If you see this H1 is a 4 second and the G is megajoule per MVA. Okay, if you are considering as a 1 MVA kind of thing. If you multiply with this, if you will get this H1 P1 plus H2 P2 S3 P3 dot plus H4 P4 plus H5 P5 is equal to H total and P total. Okay, you can just P total and utilize this formula. Okay, based upon that you can get the H, what the inertia the total system can operate when this operating together, means swinging coherently. Okay, this is the solution which I have given, that you can utilize that. You just add this P, that is the P total, and the H is such that this GH is such that 4 multiplied by 100 and 6 multiplied by 150, and you will get the inertia constant, the inertia, that is the 9.6 second. So coming to this further slides, can you please increase the sound level? Okay. Actually, is there any issue of the sound with the other people? Uh, Let me explain once again that if you see this, what I am saying that uh, you have certain components in the swing equation, that is gh by pi f, it is d square delta by dt square is equal to Pm minus P. This is electrical acceleration alpha E, and this is the delta P change, and this gh by pi f is the inertia constant m. M is the inertia constant. What I am saying that if the generators are operating together means it is actually coherently swinging. In this situation, what we do this, alpha is equal to constant in this situation, which is compensated by for the delta P. So GH is constant in this situation. And if you apply this concept in this question, this G1 H1 summation till the GH G5 H5 is equal to G total and H. And here what is G? G unit is megajoule per MVA, that is actually energy. Energy, what is the energy? That is the power multiplied by time. And the H is MVA, base. If you are taking the constant base, you can just neglect all from all. Okay, megajoule is such that the power multiplied by time. Are you getting my point?
No, actually, that no was for the sound problem.
Have you any doubt in that?
No.
Okay, okay, okay. Okay, thank you. Coming to this further slides, that is this available kinetic energy in the Indian scenario. If you see the year-wise distribution, that from 27 to 2022, the kinetic energy which was actually can be there when the RE penetration was very minimal. If you see this line, the inertial support is very high. The energy which can be utilized during a sudden change of frequency deviation, is very high. That if you see this Pmax level, and as the RE penetration increases, if you see this stored kinetic energy drops down. So why this is happening? Because there is a no moving part inside of this RE generation. Only the wind is one kind of firm is there where the stored energy can be utilized, but not with
Sir,
this.
presently you are not
Suppose you
audible.
have a battery banks. Yeah, the methodology I have told you, one of the way you can utilize that. Okay.
Yes, yes.
Now I am audible. Okay, thank you. So if you see this image, I will explain the again here. If you see this initially when the RE penetration in the 2017 to 2022, when the RE penetration is lower, this blue line is for the when the RE penetration when the initial 2017 level, and this yellow curve is for this 2018, and this 2022 is the red point. If you see the RE penetration got incremented during this 2022 very high. But if you see this when the RE penetration was the available kinetic energy, when you increase this RE penetration during the whole year, if you see the stored kinetic energy got dropped down. If you see the RE, as the RE penetration increases, the initial support which can be provided got dropped down. Inertial support. So that is actually an issue with this RE penetration. Only the wind farm have a certain rotating part, that is a DFIZ based system, or certain rotating parts that have one rotor based generation, that is if type 3 is there and type 2 is there. And in the type 4 itself, there is a one rotating part, only one rotating part. And if you see the power electronics interface, that is a more advanced in the type 4 wind farm. And the inertia in the type 4 wind farm is lower as compared to type 3 wind farm. So the kinetic energy, mean kinetic energy, if you see from the whole year-wise comparison, it is actually lowers down from 2019 to 2022. Same happens with this actually. Here, if you see 2017, 2018, this is the actually when the larger amount of this wind farm installation was there. And same happens with the kinetic energy, max kinetic energy which can be supplied. So if you see the maximum kinetic energy, it falls down. So inertia support you need to actually utilize for this sudden change in frequency deviation, which here has been explained through this European interconnected power system. If you see, If you see this delta PL, if the delta PL change is happening, this is the frequency nadir curve. This frequency nadir got dropped down. If you see here, this nadir got dropped down. What is frequency nadir? If you see in the right side figure, during this when the generation is equal to demand, then the frequency is actually at a nominal or the rated value, that is 50 Hz. This is the 50 Hz, suppose, considering. So sudden load event happen. Suppose there is a sudden load event happen. At that particular event, the frequency drop down. Frequency drop down. This is your frequency response. That is the rate of change of frequency. That is delta f by delta t. And this comes to a lower point, at a very lower point, that is actually called as a frequency nadir. That is the lowest point at which the frequency can achieve, can go. And if you see the Rokov of the second situation also, during this higher inertia, this nadir is lower. This nadir, the frequency dip is lower as compared to the higher in the higher inertia system as compared to the lower inertia system. Okay, so this is a concept of the frequency nadir, and same has been visually explained here, that if the delta P actually increases, the percentage penetration, the delta P got increases, so the frequency nadir got dropped down. Frequency nadir got dropped down. Why? Because the delta P support is actually provided. Okay, in this situation the nadir is lower as compared to when the lower inertia is there. Same with this RE penetration. If you see from 20 to 40, then 60% RE penetration, if you see, the frequency drop down is happening. The frequency nadir is actually. So this is the situation with this Rokov also, rate of change of frequency also, for this thermal and the hydro-based power plant. The same concept is there. The high inertial system is actually have a lower nadir, and this, if you can also, this rate of change of frequency is also lower. So what is happening, that if you see this 5%, 15%, 30%, 45%, 60% RE penetration, the inertial response, that is the response, is very, very actually low. That is 8.71 when the lower penetration is there. You can provide a support of 8.771. Then 15, you can provide up to the 7.71 seconds. 30, you can provide till 6.21 second. And if the 60% inertial support is inertial 60% RE penetration, then you can just provide for a 3.21 second. For a 3.21 second this inertial support. So that is actually an issue with this this RE penetration. This is also explained with this frequency curve also. If you have a generation and this load imbalance, then the frequency got changed. Based upon this, you need this frequency support to manage this frequency at a nominal level. There are certain control strategies. Control strategies in such that first is the inertial response. Why? Because the first thing you encounter during this delta F change is your inertial response. After some certain duration, suppose the inertial response is 3.21 second, it can provide the half j omega sm square, the stored kinetic energy. What after 3.721 second? If suppose okay, suppose your fault, suppose the fault is happening and it got persisted for a longer duration. Suppose the fault persisted for the 10-second duration, after that it got mitigated. So inertial response can support for the 3.21 second. What after that? For that you need certain responses, that is a control strategies. First is the primary frequency response, second is the secondary frequency response, then after that tertiary. I will explain this in the further slide with this curve itself, that is how this frequency response is utilized. And if you see this lack of this essential reliability support, there are certain issues is there. Loss of generation, the frequency deviation can occur, load shedding, then also delta F change can occur, interconnected eye lining, and also this can also leads to this vulnerability of the situation in the power stability network, power system network. This is actually, I've given the curve for this large scale PV integrated power system, the primary frequency control strategy. If you see this primary frequency support, this is the duration till which the primary frequency is being utilized. Primary frequency control response is being utilized. The slope of curve is inversely proportional to S system, that is the inertia constant of the system. How much amount of the inertial response can it provide? That is actually the Rokov. Rokov is actually dependent upon this S system, which is the inertial support provided from these primary sources. At point B, if it reaches the lowest point, then it reaches this governor response is there, then it makes the system to a certain level extent. Okay. Then the secondary control gets activated based upon this Drew based control. If you have a Drew based control, that is this P versus F curve, if you remember that. If the sudden drop in power is there, okay, so frequency got reduced. If you see this delta F change, the frequency got reduced and delta P change. In this situation, what you will do for maintaining this frequency to this nominal value, you should increase the generation. Okay. So in this kind of Drew based control, this secondary control is being utilized for the 5 to 10 minutes, and for the greater than 30 minutes, if this disruption of the system occurs, then you go for the tertiary control. Mainly what happens that till the secondary control the fault is being cleared or the abnormality with got mitigated. In the rare case of the rare event, the tertiary control can be utilized. Okay. So this is the basically the primary frequency control techniques for the large scale PV integrated power system.
Can
So
I
coming to
interfere?
this next point,
Excuse me.
that is the virtual inertia
I'm
and the
posting a
ancillary
question.
services.
Actually, I don't
So
know whether that is absurd, but
yeah,
still I'm
sure.
posting it.
Yeah,
Uh, Now we have one
yeah,
nation, one frequency. Okay, India is a whole connected system.
yeah,
So the inertia number will be very high.
yeah,
Okay, we are speaking of a
yeah,
system where we are having currently some close to 20% RE penetration.
yeah,
Maybe
yeah.
it goes to 100%, but still it is going to be a large interconnected system, right?
Okay.
So means that
Yeah,
LGB can be catered by a source at somewhere.
yeah, yeah.
uh, you are particularly speaking of this time frame of this short time
Okay.
span in which this low frequency weather that can occur, that is going to cause some
Yeah.
problems. Okay, so
Hmm.
this UFR relays, this under frequency
Yeah.
relays and all, in
Yeah.
what time frame it is going to operate? Because in this short time span, will this
Yeah.
UFR act and cascading event happens, or such issues can occur? Did you get my question?
Oh, actually, yeah. Actually, what is happening that suppose if you see the Grid India website itself, they have a certain kind of this relays are there. So if the LG fault and this lower level of this faults occur, there's a LG and double LG kind of fault. Not I'm going to this triple LG fault or triple L fault. What actually there? They take only a few millisecond to operate that relay and just set the loop. Okay, in that situation, that is a much lower as compared to this primary frequency response control what is being provided through these synchronous generators. Okay, so if you just during this the LG fault occurs and you just trip this relay, what will happen that you have cleared the fault, that is fine, but what is the reliability? You have made the node unconnected to the system. The large power demand which is being occurring at that situation, so that the reliability issue can happen. So what I am saying that when you have a synchronous generator installed in the large quantity, then the primary frequency response can be provided from that situation itself. so that you get the 20-30 second frame from that the primary response systems, that is synchronous generators, so that you can clear the fault based upon the situation by checking that how the vulnerable your system is by mitigating that fault at that situation. Okay, so that is the main criteria, that reliability issue. Suppose the fault come at the commercial node. Suppose the large number of commercial nodes are there and the certain fault came. You cannot actually take this account that you should just strip the relay and make the whole node got interconnected. So for that you need a certain time frame to realize that how the vulnerable situation can be
Yes,
during
yes,
this kind
exactly.
of control measures if you take. Okay, are you getting my point, the Google? Okay, thank you. Let's moving forward move to this virtual inertia and the ancillary support. This virtual inertia concept is such that if the RE penetration got increased in the future, then what is happening that we have the inverter based resources in the large amount. Okay, so what is the virtual inertia is they realized by implementing the control function on the power electronic interface, the RESS, to mimic the CSG inertial dynamics and provide the inertia virtually. Okay, so in this situation, what we will do, you have a certain DC link in between this interconnector, this inverter based DGs. So what is he saying that this virtual inertia is the short-term stored energy in the DC link of the RES power converters, which should be injected to the AC side according to the virtual inertia control object. Okay. Suppose you need the inertial support before the primary control should operate for a suppose 1 second duration or less than 1 second duration. You can provide the power from this DC link capacitor based system, that is half CV square. You can utilize that energy. So this is the this dynamics. For utilizing this dynamics, it is also important that your control strategy should change. What control strategy you want to utilize, that depend upon your features, where you are actually implanting that is where you are providing that initial support from that. Okay, so coming to this one of the example related to this DC link, uh, I have given one question. This question says that you have a renewable energy source which utilizes a power converter with a total short-term stored energy capacity of 500 kilojoule in the DC link. If the system operator at an average power output of 50 kilowatt, calculate the virtual inertia constant of this RES power converters. Okay, you just have to tell me that how you should utilize this energy at a what time frame. Okay, I will explain this because of this time frame. The time is also less. So what is happening that you have a certain DC link capacitor and you have a certain converter. And what I'm saying that you should utilize this DC link based upon if you have this. Suppose this you have a battery bank is there, and you have a certain stored energy here, and also it can be possible that you have a number of this RE generating system, that is suppose the PV is also connected through this DC bus bar. It can also happen. So what I am saying that DC to AC conversion can take place through this power electronic converter, and you can utilize this for this inertial support. So 500 kilojoule is the energy which is being available. Okay, and what is the utilization, that average power output, that is a 50 kilowatt. Okay, so if you multiply this 50 kilowatt with this time frame, you can get the time frame for which you can utilize that. Okay, for the 10 second you can use that. This inertia constant is H virtual is for the 10 second. Okay, so that is the main crux, that how much utilization you can take based upon that how much demanded. This is the, and second, I want to explain you that frequency support based upon this RE penetration. If you see that these are the definitions which I have already explained, and there are certain response time, and based upon that primary secondary as there, it also have a certain time frame. What I explained during this large scale PV connected system, that secondary frequency control is greater than this 30 minute is there, and this is say primary control is for the some few minutes, and this inertial support is for few seconds. Okay, so coming to this next part, that is the sources of this virtual inertia. There are certain sources. Suppose you have a conventional synchronous generation, DFIG based wind turbine generator, that is a type 3 wind farm. PMSG based wind turbine, that is a permanently magnet this synchronous generator based wind turbine generator type 2. PV arrays, this is type 1. And then demand response. You can see that from where you can provide the inertia and the active power control. The inertia can be provided through all the generating points except the PV array. Why? Because you cannot provide the certain power from this PV array. If you have this battery storage, you can provide. Okay, and also this Z star. If you see this Z, this star term is there. This is a synthetic inertia. Synthetic inertia in what sense? It is possibility that with the deloading and the corresponding control mechanism, you can utilize that based upon the certain situations. Okay, but you cannot utilize all the time. Okay, because when the wind is no wind is there, so how can you utilize by just rotating and utilizing that? Okay, it should be during the rotating part you can utilize that synthetic inertia. And you can see that if the active power control is possible in the all conditions, whether it is a conventionally synchronous based generation system or the PV array or the battery storage or the
Yeah,
demand response is
if
there,
we are
you can
curtailing the
utilize the
power
active
of the
power control
PVRA
in
system, that
all
means,
situations.
say,
Okay.
let
Coming to this,
you're maintaining it
yeah,
40%, you'll be
yeah,
having a recess power, right? That recess power could be used for inertia control, right? PVRA from that PVRA.
Yeah.
yeah.
Yeah,
Yeah,
that
that
can
can
be
be
utilized,
utilized,
but
but you
you cannot
cannot
force
force
the
the
PV
PV
array,
array.
na?
No,
Though
though
you
you
have
have
a
a
certain
certain
DC
DC
link
link
capacitor
capacitor
is
is
there
there
from
from
where
where
it
it
is
is
being
being
connected,
connected,
and
and
you
you
have
have
a
a
some
some
MPPT
MPPT
algorithm
algorithm
which
which
is
is
working,
working,
acting
acting
for
for
the
the
DC
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 boost
boost
converter
converter
kind
kind
of
of
thing.
thing.
But
But
you
you
cannot
cannot
force
force
the
the
PV
PV
array
array
to
to
generate
generate
that
that
power.
power.
But
But
when
when
the
the
ability
ability
is
is
there,
there,
you
you
can
can
utilize
utilize
that.
that.
But
But
I
I
am
am
saying
saying
that
that
during
during
the
the
sudden
sudden
change,
change,
suppose
suppose
if
if
this
this
problem
problem
occurs
occurs
in
in
the
the
evening
evening
itself,
itself,
you
you
can
can
consider
consider
this
this
PV
PV
array
array
as
as
a
a
inertial
initial
support
support
kind
kind
of
of
thing.
thing.
You
You
cannot
cannot
control.
control.
You
You
cannot
cannot
say
say
that,
that
because
because
if
if
you
you
are
are
saying
saying
the
the
PV
PV
array,
array,
but
but
during
during
the
the
generation
generation
of
of
this
this
morning
morning
time
time
and
and
this
this
morning
morning
peak
peak
kind
kind
of
of
thing,
thing,
you
you
can
can
say
say
that.
that.
Okay.
But
But
you
you
cannot
cannot
say
say
in
in
the
the
Okay.
generalized
generalized
fashion.
fashion.
But the
But the
fault
fault
can
can
occur
occur
in
in
the
the
any
any
time,
time,
no?
no?
Yeah.
Okay.
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 Dhanji
Dhanji
Singh,
Singh,
please
please
repeat
repeat
this
this
virtual
virtual
inertia
inertia
concept.
concept.
Okay.
Okay.
Let
Let
me
me
explain.
explain.
Let
Let
me
me
explain
explain
to
to
this
this
virtual
virtual
inertia
inertia
concept
concept
through
through
this.
this.
What
What
I'm
I'm
saying
saying
that,
that,
Dhanji,
Dhanji,
what
what
I'm
I'm
saying
saying
that
that
if
if
you
you
have
have
a
a
certain
certain
storage
storage
system,
system,
suppose
suppose
you
you
have
have
a
a
PV
PV
based
based
energy
energy
storage
storage
system,
system,
I'm
I'm
saying
saying
that
that
you
you
should
should
keep
keep
a
a
certain
certain
margin.
margin.
Margin
Margin
is
is
what
what
sense?
sense?
Suppose
Suppose
the
the
PV
PV
PV is
is
there.
there.
After
After
that,
that,
you
you
can
can
put
put
it
it
into
into
the
the
storage
storage
system,
system,
that
that
is
is
the
the
battery
battery
storage energy
energy
storage
storage
system.
system.
Then
Then
suppose
suppose
this
this
is
is
the
the
Pmax
Pmax
level.
level.
You
You
can
can
utilize
utilize
from
from
that
that
energy
energy
bank.
bank.
But
But
you
you
should
should
give a
give a
certain
certain
margin.
margin.
Suppose
Suppose
you
you
are
are
utilizing
utilizing
is
is
at
at
this
this
P
P
critical
critical
level.
level.
So
So
P
P
critical
critical
to
to
P
P
max
max
is
is
available
available
energy
energy
all
all
the
the
time,
time.
and
And
you
you
are
are
utilizing
utilizing
that
that
P
P
min
min
to
to
PC.
PC.
So
So
when
when
the
the
sudden
sudden
frequency
frequency
drop
drop
or
or
sudden
sudden
frequency
frequency
change
change
can
can
occur,
occur,
you
you
can
can
utilize
utilize
this
this
P
P
max
max
minus
minus
PC.
PC.
So
So
this
this
is
is
the
the
virtual
virtual
inertia.
inertia.
You
You
don't
don't
have
have
any
any
rotating
rotating
part
part
in
in
that,
that,
but
but
you
you
are
are
making
making
this
this
system
system
to
to
operate
operate
in
in
such
such
a
a
way
way
so
so
that
that
it
it
can
can
provide
provide
and
and
help
help
in
in
the
the
frequency
frequency
deviation
deviation
situation.
situation.
So
So
this
this
is
is
a
a
kind
kind
of
of
virtual
virtual
of
of
the
the
synthetic
synthetic
inertia.
inertia.
Same
Same
happens
happens
with
with
this
this
DC
DC
link
link
capacitor,
capacitor
which
with
DC
DC
link,
link,
which
which
is
is
actually
actually
being
being
connected
connected
this
this
renewable
renewable
energy
energy
sources
sources
converters.
converters.
This is
This is
also
also
you
you
cannot
cannot
have
have
any
any
rotating
rotating
part
part
which
which
have
have
this
this
half
half
J
J
omega
omega
Sm
Sm
kind
kind
of
of
storage
storage
energy.
energy.
It
It
just
just
such
such
that
that
it
it
have
have
a
a
certain
certain
energy
energy
which
which
is
is
being
being
stored,
stored,
that
that
RC
RC
V
V
square.
square. you can utilize it for the few seconds, and it is virtually available, not all the time. Okay, but when it is available, you can utilize that. This is a concept of this virtual or synthetic energy. Okay, are you getting my point? So this is the one question. I request everyone to solve it. Try it. Let me remove exactly this.
Actually, the pen marks are overlaid on
The
that.
question is visible. There's a question. Yeah. Don't know what is happening. It is happening to the all the slides. Let me check. Disconnect. Uh, it is not being able to remove. If you read the questions, you can try that. Meanwhile, I am trying to mitigate this issue. Meanwhile, if you are able to read that, okay, then this one question is there. But in PV, how we can store the energy so that we can use whenever we want? That is the same concept. What I have told you that you should give a certain margin ability so that you can utilize during the demand time. Okay. So in whole of the situation, when this energy storage system can happen, that you should give the certain margin to that. Let me, this issue is not resolved. So I am just reading the statements and the time is less. Uh, I'm reading the first statement says that it is saying that renewable energy source RES have unlimited potential to provide frequency support services due to their inherent variability. That is
It's
actually,
false.
Gokul, you want to say something? One second. Uh, has unlimited potential. That is false. That is false. Second part is such that demand response programs can only occur frequency support services during the peak demand period and are ineffective during the low demand hours. This statement, anybody want to answer? That is false. It can provide, no, because the margin, what I'm saying that it is available all the time. Suppose you want to utilize in the peak time itself, then you can. But if the fault occurs in the non-peak hours, you will do? In that situation also you have to utilize, no? And the third statement is says that one limitation of the renewable energy sources for the frequency support is their inability of to provide inertia to stabilize the grid during the sudden frequency deviation. That is true. That is true. And the fourth statement is such that demand response initiatives cannot contribute to frequency support services because they are primarily focuses on reducing energy consumption rather than providing additional energy. That is false. That is false because it can utilize. You can buy the energy from this demand response systems, which have already there. It can participate in the energy market. Last is the intermittent nature of the renewable energy sources makes them unreliable for providing continuous frequency support services, especially during extended period of the renewable energy generation. That is true. So this problem, I will upload this slide. You can go through it and you can
Demand
check the
response
these questions and
frequency
solve
control.
by yourself if you
Actually,
come to
that
clarity. Okay.
also requires time,
Further,
some
I'll
minutes
move.
of time frame, right? Demand response is something
Yeah.
that happens over a period of time. We will not get any immediate control from demand response.
Yeah. You,
Okay, okay.
yeah. But you can utilize this for the tertiary control. No. Yeah. I'm just saying that what is available and what is being utilized. So first response is always with the initial support through the conventional generation or the margins which are available is available. And the second is that through those droop controls, and after that you can go and buy from there which is available in the energy market. Okay. And this, if you see this figure, this it is not visible much, but I am reading for that. Just sorry for that. Suppose if you see this inertial support, frequency control, voltage control, and the system strength. If you see the system strength is actually what is actually associated with during the fault and the short circuit conditions. This synchronous generator have this capability that to provide inertial support for, and it also makes certain strength feature, adds strength feature. If you see this frequency control, the HVDC systems, new wind farms based control system, the load setting can one of the situation, can one of the options. So these are the virtual inertia ancillary services through the virtual, if you see the virtual system generations, this is actually, if you see this, there are certain number of generations are there. So during the utilization you must have a certain control feature that which to utilize at that time. Okay, so this is the main crux of this slide. Coming to this next part, that is the contagion of the inertia, which I have explained in the last slide itself, that how you will say that this is the inertia support you are providing. There are certain other equations as well. If you see this equation, that is the E system is equal to delta P multiplied by F naught to dF by dt. So during the frequency change or the delta P change, the E system can be utilized, which is a combination of the distributor, this the digital generator based system, and the VSGs which are connected to the system. Okay, based upon the factors which is the you sudden you want, based upon that this is quantified. Coming to this demand side management, if you see this demand side management, let me take the new slide and paste there. Here also it is happening. So just mark my statements. Okay, just focus on what I am saying. There are certain demand side management techniques are there. Okay, first is the peak clipping. Peak clipping is such that you have a certain load curve. Load curve means you have power versus time curve of a daily basis. This is a daily load curve. So there are two peaks mainly observed, morning peak and evening peak. So by certain methodology management, if you decrease that peak which is occurring in the morning and the evening, that is actually the peak clipping. Now you are operating at this point, not this P max point. Okay, and same with this valley filling. If you have a certain this what I am highlighting, if you see that, just uh, just fill the valley means shift this to this point and shift this half of this extra power to the left side. This is a kind of valley filling. And load shifting is one of the time that you should not operate your equipment at the peak time, and shift the load for the other non-peak hours. And there one more method is there, conservation. Conservation is such that you should conserve that extra energy which is being there and during and utilize when the demand is needed. And the load growth is such that utilizing of that energy which is being stored, and the flexible load, as you have a controllable load. Suppose In your house itself, you have certain kinds of load. So you have refrigerator, you have HVAC system, that is a air conditioning system, you have oven itself. So what is happening that it is a certain kind of make it as a controllable loads, which is operating based upon your situation. Suppose one central management is there, which is giving certain command to you that for the demand response participation, such that you should stop this refrigerator, or you cannot stop the refrigerator, you should stop the AC which is being utilized, so that you can shift or flexibility, you can control this load, and you can use the oven in the some other time frame. In that situation you can earn money also. In there are two kind of situation, that win-win situation in for the both central management system or discoms, and also with you also. This will I will explain in the further slides. If you see, this is not completely visible to you. I will give these slides to you for the utilization, and the time is also not. This is the demand side process. Suppose you have a residential, commercial, industrial, and the consumers. In the central, you have aggregator which is being communicating with this distribution system operator (DSOs) and independent system operator as well, for making the giving the command to the residential, commercial, industrial loads to utilization, what kind of load you should utilize at that particular situation. Okay, that procedure is such that for the this ISO determine preferred demand volume and the time derivation that is offered. Then the aggregator receive the load data from the ISO. Then the aggregator select the consumer for their participation into the demand response program depending upon their ability. Then the accounting the number of interested customers agreeing to the proposed demand response, and the aggregator optimizes the total demand based upon the how much houses or the commercial building are there participating in the demand response. Then that data comes into this reported to the ISO and the local distribution generator for providing this demand response. And there are certain architectures also based upon this. Utility center is there at the upper end, which is communicating with this distribution system controllers and the smart meters itself, for basically such as situations such that you should operate the equipment only when there is a off peak load is there. This is the situation for the discom itself, that they cannot provide a surplus energy at that particular situation. What they do, they generally set the load. Setting of the load is not a actually a good solution. So that's why they go for this demand side management kind of thing. And this is the architecture related to this in microgrid. And this is the one question. This is a simple question based upon the tariff based issue, tariff based utilization of the power of the off peak and the non that is the non peak hours. And the one of this classification of the defined response, that is the based upon this control strategy, price based, time of tariff based, time of utilization based, and the load based. There are certain centralized and decentralized control. Suppose this is a control strategy which is centralized and decentralized. Apply that same concept of this cyber attack which I have explained into this demand response. And other is the time price based, that is the time of use and the time of price, because you should utilize your equipment when the tariff is low, and use that amount you that is the energy saving and the cost saving also. Energy saving for the discoms and the cost saving for you. So there are win-win situation for the loads, demands also, demand responses also, and the discom also. And I have given one question also, you can try, and in the next class we will discuss this question, that if you have any doubt. Okay, and the solution we will give at that. So that's all from my side. There was some issue with this, so I hope I have cleared some of the points. So Dharni have one this doubt That is the X by R ratio concept. So let me explain you, Dandi. Just uh, go through my statements. What I am saying that X by ratio is such that there are certain time constants are there from where the energy can be. Suppose there is a strong gate. Strong gate means the X by ratio is high. X by R ratio is high. One in what sense? The time response which is given during this disturbance, that is a delta P chain, that is actually high. Means the time is low for that response. That concept you can say that this is a strong grid. And in the weak grid concept, if you see that there is a certain delta P change is there, so weak grid that cannot be response at a faster rate, and in that situation, okay. So in that case, that you can say the X by ratio is low. So if you use the MATLAB also, MATLAB if you have used, you have a certain block that is a three-phase source. In the three-phase source, you have a two features are there. In features, you can provide this X by R ratio. That calculation you have to do search for certain. I will share some of the research papers that how you determine this, what kind of X by ratio you should put. Based upon that, you should make this three-phase source as a strong network, strong system, providing this for the delta P chain. And based upon the X by ratio, you make the your grid as a weak grid based upon the response itself. Okay. You have any other doubt, Dharni or Gokul, Devin? Any other doubt, or I should stop this session? Sorry for the this slides. I will explain this. I will give you these slides, and you should must go through these problems. These problems are very important for the understanding of this time of utilization and the time of use. Okay. After that, in the ninth tutorial session, if you have any doubt, we will discuss in that. Okay. Thank you so much, guys. Thank you so much. Okay.